Hello. In this video, we'll be discussing review problems for the GRE Quantitative Reasoning section. This is the first of several videos discussing such problems. As a disclaimer, I do not own the following problems. They are taken from the Manhatten Review website. My work will be my own on each of these problems, but the contents of the problems themselves are owned by the Manhattan Review. Moving on to the first problem, consider the following. Let x and y be numbers such that their product is greater than 0. That is, x times y is greater than 0, as given here. Then, we wish to compare two quantities, quantity A and quantity B. We wish to say whether one is greater than the other, if the two are equal, or if the relationship cannot be determined from the information given. Well, since x times y is greater than 0, we have two options. Option 1 is that x is less than 0 and y is less than 0. If both x and y are negative numbers, then their product is greater than 0. Alternatively, we have the option that x is greater than 0 and y is greater than 0, because the product of two positive numbers is again positive. Notice that we don't have the intersection. We don't have a case where x is less than 0, but y is greater than 0, or the other way around for y and x. So this sort of situation is not allowed. So we wish to say whether x squared times y to the fourth is greater than, less than, or equal to x cubed times y to the sixth. However, without knowing the actual values of x and y, or knowing some other equation of constraint for them, we can't determine anything else. For example, consider the following. Let's say that x is equal to 1 and y is also equal to 1. Then we see that x squared times y to the fourth is equal to 1, and that's also equal to x cubed times y to the sixth. So these are equal. However, if we have x is equal to negative 1 and y is equal to negative 1, then x squared times y to the fourth, well, these are both even powers, so this would be equal to 1. However, x cubed times y to the sixth, the negative 1 to the sixth for y to the sixth, that would be equal to 1. But negative 1 cubed is equal to negative 1. So this is equal to negative 1, and they're not equal to each other. So the relationship between these two quantities depends on the values of x and y. So the answer here is D. The relationship cannot be determined from the information given. Next, consider the following figure. In the figure shown above, line segment BC has a length of 16 centimeters, so we'll label that 16. Rectangle FABE, so the left rectangle here, is a square, so that means we can identify each of these four side lengths. So drawing one line across each of these side lengths just says that they're equal to each other. Alternatively, we could say that each one has a side length of x. So we move on. We say, and the area of the rectangular region FACD, so this entire outer box here, is 612 centimeters squared. So we know that this entire rectangle, FACD, is in fact a rectangle because it's stated that it's a rectangular region, FACD, and it has an area of 612. So automatically, we know that the opposite side lengths should be equal to each other. So we know that CD is equal to x in order for this side length to be equal to this side length, because it's a rectangle. And we know that ED is equal to 16. And that's to ensure that AC is equal to FD to make this a rectangle. So we know that the area of the total rectangle is 612. So we have 612, but this is equal to the area of each box added together. So the area of AFEB is equal to x squared, or one side length times the other, since it is a square. Then the area of the rectangle BCDE is equal to 16 times x. So we add that to x squared. And this sum on the right should equal 612. So we solve for x as follows. We get all of the terms onto one side. So we have x squared plus 16x. We subtract 612 from both sides. And this is now equal to 0. But this is an equation that can be solved using the quadratic equation. So we say that x, the solution, is equal to negative b, so negative 16, plus or minus the square root of b squared, so here b is 16, so 16 squared, minus 4 times a is the coefficient in front of x squared, so that's 1, times c. C is this constant here, so it's negative 612. And we divide by 2a. So here a is 1, so 2 times 1, that's just equal to 2. So we get that x is equal to negative 16 plus or minus the square root. Well, 16 squared is equal to 256. And 4 times 612, well, we notice that the negatives cancel. So this negative cancels with this negative. So we get plus, and 612 times 4 is 2,448. I should note that for the quantitative reasoning section on the GRE, you can use a calculator, so you don't have to do all of these calculations in your head. You would just plug it into the calculator on the screen. Then we can add these together, and when we take the square root of their sum, we get that this is equal to negative 16 plus or minus 52 divided by 2. So this is equal to, well, if you do the minus first, it's negative 16 minus 52. So negative 16 minus 52 is negative 68 divided by 2. That's one solution. And the other solution is negative 16 plus 52. So that's equal to 36 over 2. And these two are equal to, well, negative 34 and 18. But remember, those are two possible values for x. We know that x can't be negative 34 because that would mean the side length is a negative 34 centimeters. And it doesn't make sense to have a negative length. So we know that 18 is the true value of x. So we find that x is equal to 18. Then we wish to compare the following. Quantity A is the area of FABE, so it's equal to the area of the left square here. And quantity B is the area of EBCD, so the right rectangle here. And we wish to compare these two, or at least to compare their areas. Doing so, we know that the area of the left square is x squared, so it's equal to, so A has an area of 18 times 18, whereas B has an area of, well, you just multiply the two side lengths, so it's 16 times x, or 16 times 18. But we know that 18 times 18 is greater than 16 times 18. So we know that quantity A is greater than quantity B. So the answer here is A. Moving on to the next problem. Consider the following. Working independently, machine A can complete a certain amount of work in 3.5 hours, while machine B can complete the same amount of work in X hours. Working simultaneously, they together complete the same work in 1.5 hours. We wish to compare the quantity A, which is just 3, to the quantity B, which is equal to x. So here we need to solve for x, assuming that we can do so, and then compare that value to 3. So let's write down what we know. We know that machine A can complete a certain amount of work, so let's call it 1 work every 3.5 hours. So it completes 1 amount of work in 3.5 hours. Whereas machine B, on its own, completes 1 amount of work in X hours. Together, so A plus B, they complete 1 work every 1.5 hours. So we have what A plus B is, and we have A and B independently. So we can just add them all together. So we have 1 work divided by 3.5 hours plus 1 work over X hours is equal to the combination of the two machines, which is 1 work over 1.5 hours. Then we proceed as follows. We can do this in one of 2 ways. We can keep 3.5 and 1.5 as decimals, or if we don't want to use the calculator, or it's not working, or you can't find the calculator, you can try to convert these into fractions. Doing so, we know that 3.5, so as an aside, 3.5 is equal to 7 divided by 2. So 7 over 2 is 3.5, and 1.5 is equal to 3 over 2. So 3 halves is 1.5. Then the fractions on the left here, well, it's 1 over 3.5, but 3.5 is 7 over 2, plus 1 over x is equal to 1 over 1.5. But 1.5 is 3 over 2. So it's 1 over 3 over 2. Simplifying this, we know that this 2 and this 2 can be brought to the numerator, making this equal to 2 over 7 plus 1 over x is equal to 2 over 3. Then we subtract 2 over 7 from either side, so we get that 1 over x is equal to 2 over 3 minus 2 over 7. Then we wish to simplify this expression. We do that by cross-multiplying. So we multiply the numerator and the denominator on the left by 7. So what we're doing is we're multiplying by 7 over 7, which is equal to 1. So it doesn't change the value of the fraction. And then for the right term here, we multiply by 3 over 3. So we multiply 3 in the numerator and 3 in the denominator. What this does is it gives us the same denominator for both fractions, so we can add them together. So doing so, we have 14 over, so 7 times 2 is 14, divided by 7 times 3, which is 21, minus 2 times 3, which is 6, divided by 21 again. Since these have the same denominator, we can add them together. So this becomes 14 minus 6, which is 8, divided by 21. Then we take the reciprocal because we want to solve for x. So we find that x is equal to the reciprocal of 8 over 21, which is equal to 21 divided by 8. Notice that 24 over 8 is equal to 3. And since 21 is less than 24, this quantity here, x, is less than 3. So we find that quantity A, 3, is greater than quantity B because x is less than 3. So the answer here is A. Moving on to the next problem. Consider the following. A driver completed the first 20 miles of a 40-mile trip at an average speed of 50 miles per hour, and the second 20 miles at an average speed of X miles per hour. The average speed for the entire 40-mile trip was 60 miles per hour. Assume that the driver did not take any stops during the 40-mile trip. We wish to compare the quantity A, which is X minus 60, to quantity B, which is 10. So, this trip is split into two equal parts. The first half of the trip, so you have this strip here, which tells you the entire length of the trip. And we can split it down the middle. So for the first half, the driver travels 40 miles per hour. For the second half, the driver travels X miles per hour. And the total is an average of 60 miles per hour. So the average of 40 and X is equal to the following. We say that 40 plus X divided by 2 is the average of these two values, and that should be equal to 60, which is the average speed over the entire trip. So, solving for X, we multiply both sides by 2 to get 40 plus X is equal to 120, which is 60 times 2. Then, subtracting 40 from both sides, we find that X is equal to 80. So we found X. Then, quantity A, which I'll write up here, quantity A, let's use white, quantity A is equal to X minus 60, which here, since X is 80, we say it's 80 minus 60, which is 20. And quantity B is 10. Clearly 20 is greater than 10, so quantity A is greater here. So again, the answer is A. Next, moving on to the final problem, we have the following. A positive integer x is a perfect number if the sum of all of the factors of x, including 1 and x, is equal to 2x. We wish to compare the following quantities. Quantity A is the sum of the reciprocals of all of the factors of the perfect number 28, and quantity B is 2. So first, we should write out all of the reciprocals, or at least all of the factors of the perfect number 28. So we know that 1 is a factor of 28, and moreover, we multiply 1 by 28 to get 28. So that means 28 itself is also a factor of 28. Then, since 28 is even, 2 is also a factor of 28. And 2 times 14 is 28, so 14 is also a factor of 28. Next, 3 is not a factor of 28, but 4 is, because 4 times 7 is 28. So that means that 4 and 7 are both factors of 28. And since 5 and 6 are not factors of 28, we see that this is an exhaustive list of all the factors of 28. So, we should sum all of the reciprocals of all of these numbers. That is, we wish to compare 1 divided by 1 plus 1 over 2 plus 1 over 4 plus 1 over 7 plus 1 over 14 plus 1 over 28. We wish to compare this to 2. Well, in order to add all of these together, they all need to have a common denominator. So we proceed as follows. We say, well, the first term you can say is equal to 28 divided by 28. Because 28 over 28 is still 1 over 1. It's the same thing. Plus 14 over 28, because you need to multiply 2 by 14 to get 28. So what we do is we multiply the top, the numerator, by 28 and the denominator by 14. So both are multiplied by 14. And since you're multiplying 1.5 times 14 over 14, it's the same thing as just 1.5, but we get 14 over 28. Continuing for all of these, we see for 1/4, we have to multiply the top and the bottom by 7. So we get 7 over 28. For 1 over 7, we have to multiply by 4 over 4. So we get 4 over 28. For 1 over 14, we have to multiply by 2 over 2. So we get 2 over 28. And 1 over 28 already has 28 in the denominator. So these are all equivalent to the factors above. But we can now sum all of the numerators together. So we get the following. We know that 14 is equal to 7 plus 7, and 4 plus 2 plus 1, so these three added together is 7. So these sum to 7. Then 7 plus 7 is 14. So we have 28 plus 14 plus 7 plus 4 plus 2 plus 1. So that's 28 plus 14 plus 14. But 14 plus 14 is 28. So we have 28 plus 28 divided by 28. But that's just equal to 2 times 28 over 28. And we can cancel the 28 in the numerator and the denominator. So we get that this sum is equal to 2. So what we find is that the sum of the reciprocals of all the factors of the perfect number 28, or quantity A, is 2. But that's exactly equal to quantity B. So the answer here is C. The two quantities are equal to each other. And this concludes the first session on GRE Quantitative Reasoning problems. Thank you.